Hello, my name is Daryl Whiteside. I'm the Regional Sales Manager from Access International, and today I'm going to be talking to you about dancer tension control systems. And we're going to be going through this demo that's right here in front of us. But first I want to talk about, dancers and why you would use a dancer system. Dancer systems are a little bit different than load cell systems, where you just have you're both closed loop, but in a load cell system you're actually just measuring the tension directly, but you have no accumulation available for changes in web velocity. In the case of a dancer system, we literally have what we call a dancer arm that moves up and down. So why would you use this versus a load cell system? Well, in cases of indexing applications where you're starting and stopping the web, perhaps you're stamping or doing something to it, or doing a crosscut or sheeting, the dancer system allows the unwind roll or the rewind roll, depending on which one you're controlling, to continuously move, so we're not having to deal with the inertia of starting and stopping a large roll. So the roll goes continuously, the arm moves up and down to absorb that velocity change. Another place that they're typically used are in cases where you have out-of-round rolls, perhaps they're stored incorrectly, you've got a flat spot on it, or it's an egg-shaped roll, and you have this loping effect as the roll unwinds. The dancer would actually accumulate that velocity change again and actually take that up to give you a continuous run on the unwind or rewind, depending on where you're using it. Now, there's a lot going on in a dancer system. There are a lot more components than we have in a load cell system. In the case of a load cell system, the brake or the clutch, in the case of a rewind, are actually setting the tension. We're either holding back or we're pulling more or less to set the tension. Dancer systems are different, and this is where the confusion comes in. In the case of a dancer system, the actual tension is set by the load, whether it's an air cylinder or some other loading device that's on the arm. That's actually setting the tension. The job of the control, the dancer control of the brake, their sole purpose in life is to keep that arm from hitting the bottom stop or the top stop. So in this case, the brake isn't holding back more or less to set more or less tension. It's making sure we're not hitting those stops. So as long as our loading device is setting the tension and we're not hitting the stops, and that loading is not changing through that stroke, we have constant tension. So let's go ahead and take a look at the different components that go into a dancer system. I mentioned earlier that there are a lot of different components that go into making a dancer work correctly. And I'm going to point those out, some of which we make, some of which are third party, and I'll point those specific items out to you as well. I guess the first thing to start with a dancer arm is dancer system is the actual arm itself. So in this case we have an aluminum arm. It has holes drilled into it to eliminate as much mass as possible. Now this arm moves up and down. This is why it's called a dancer. It's supposed to move. So you can see that it's going through this full stroke, and we drilled these holes in it to take as much mass out as possible, because sometimes this arm will do this, sometimes due to spikes or transits in the web, that arm may have to move faster or slower. And we want to make it as light as possible or as low mass as possible to take the inertia out of it, so we're not introducing tension transients or spikes with that arm. The next item that we have here is the actual air cylinder that's loading the arm. Remember I said earlier that in this case the tension is not being set by the torque device, the clutch or the brake. It's actually being set by the air or the load that's in this cylinder. Now this cylinder is a rolling diaphragm cylinder. We always recommend using low friction type cylinders. In the case of a rolling diaphragm cylinder, instead of having a piston and O-rings, what we have is actually a diaphragm or a bladder that's inside of there, and there are actually linear bearings on that shaft, so it's very smooth when it goes up and down. Okay, so that's critical, because if you use a piston type or an O-ring type, it can actually stick, and there's a breakaway force, and all of a sudden it moves freely, sticks. Those types of things, since this is the tension, this is the load in the dancer, those transients or those sticking points will introduce tension spikes into the web. So it's very important to use a low friction type cylinder. Now let's back up and let's go to the control itself. In this case we have our Versatech control, which is one of our dancer controls. And we'll be going through some of the special things that they can do. But remember, what it's doing in this case is we're simulating a rewind. So we're controlling this magnetic particle clutch from the Versatech, and we're basing that how much torque to apply here as to where that arm is off of the feedback through this DFP. This is another MAGPOWR product, the blue stuff is. This is another MAGPOWR product that's actually giving us the position feedback of the arm, so that control knows how much to output, more or less, to keep that arm basically in balance. So we've got the magnetic particle clutch, we've got the control, we've got the position feedback sensor. You'll note here we also have an ultrasonic sensor. Now in this case, if you look at this screen, it's actually showing a diameter of the roll. And what we use that for, we use that for a couple of things. Well, it can be used for multiple things. It can be used for an end of roll alarm. So it can, when you reach a certain diameter, it can turn on a light to tell the operator to come back that he needs to change the rolls. It can be used for taper tension. In the case of a rewind, what you need to do sometimes is actually reduce the set point, reduce the air pressure in this cylinder as the roll gets bigger. If you don't do that, you can cause things like crushed cores, starring, so that's a pattern that appears in the end of the roll, excuse me, as well as telescoping to where the roll is running off. So those are all things that indicate that you need taper tension. So that's things that the US2 can do. Now the last thing that we use it for, and probably one of the most common things, would be for gain scheduling. And what gain scheduling is it actually is changing the parameters of the control loop. Now when we talk about gain, that's the proportional gain, that's the P in a PID loop. And that's how much the control reacts to a given error. Now, in the case of a roll of material, a large roll requires a lot more gain, a lot more reaction to make a change. Once you get down to core, you do not require as much gain, and you can actually overshoot or become unstable. And this is a lot that has to do with the inertia of the roll. So what we do in a traditional system without gain scheduling is you kind of pick a compromise. The p-value ends up being something between core and full roll. But if you're running really big rolls, really large roll builds, what can happen is at full roll, that compromise isn't working anymore, and you might be oscillating, where you have a very slow movement back and forth, and you might be bouncing off of the stops. But by the time you get down to core, you have very erratic movement of the arm. And that's because you don't have enough gain at full roll, and now you have too much gain at core. So what we do with gain scheduling is we actually monitor the diameter of the roll and reduce the gain as the roll gets smaller, so you can run any roll build that you need. Another item that's on here, you can see we have one of our current to pressure transducers. So that's actually controlling the air. We're sending an electron at 420 milliamp signal from the Versatech through the current to pressure transducer to get our air pressure into the air cylinder. So you can use that just as a regulator to set the tension. This is also critical in the case of the taper tension in a rewind, because what we're doing here is as that roll gets bigger, this thing is automatic, the Versatech, the control, is actually reducing the air pressure to this cylinder. Because remember, this cylinder is the tension in the web. So as the roll gets bigger, we're backing off on that air pressure, reducing the tension. Another thing we have on here, this is static back here, but we did include a magnetic particle brake, which would be included on the system. And the last component that I really want to look at is this air cylinder. There's an not air cylinder, but a tank, a reservoir that's on the back side here. That's very critical, because if you look at the air line going to the cylinder, it's typically going to be a smaller diameter, and the longer that run is, the more of a lag. You know, the air has to move, and there's a delay there. If we don't have the air available right here, if that arm has to make a dramatic move, it can actually change the pressure in this cylinder, either making a spike in the tension or making it go slack. Either way, you're putting a tension transient in, and you're actually changing the tension, because again, this is the tension. So now that we've gone through that, now let's start looking at how you set the system up and the control. So now let's go ahead and talk about the setup and tuning of this dancer system. Okay, so with the machine not running, so we have not turned the machine on yet, we've identified and we've put in all of the correct parts that go in the system. The first thing we want to do is set a set point for the arm to ride. Okay? We don't want it to ride too low to where it can bump into the bottom stop. We don't want it to ride too high to where it can bump into that top stop. So in this particular control, and what I'm going to show you is common for a lot of our different controls in the tuning method and the setup, but we're going to show you on the Versatech. So the first thing I'm going to do is I'm going to go in here and I'm going to hit Program. Okay? It's going to take me directly to something called Dynamic Tuning. So with the machine's not running, I'm going to hit the down arrow, and it's telling me to hold the plus and minus key to set the position. So I'm going to step in front of you a second. I'm going to hold the plus and minus key at the same time. Hold that up in the middle where I want it. And now it says OK. So that means it has memorized that point. So now when we turn the system on, it's going to actually go to that point and ride there. That's going to be our balance point where the control is always trying to drive back to. So the next thing I'm going to do, I'm going to go ahead and hit home. The next thing I'm going to do is I'm going to go ahead and turn the machine on. So when I turn the machine on, you're going to hear the motor run that's driving the clutch. Again, we're simulating a rewind, so we're going to be taking up material. But I'm going to turn the machine on. You're going to see the arm go up. So you can see here on the screen, it's reading the actual diameter of the roll, and it's giving me a 35.7% output. So it's controlling now. It's running. The PID loop is on. Now, when you first turn the machine on, just because it looks stable does not mean that it's tuned. A properly tuned system, and when I talk about tuning, it's tuning the PID parameters. A properly tuned system needs to be right on the edge of being unstable, because we need to be able to react to any transients that might come along. If we don't do that, even though it looks stable, it might just be sluggish right now, and we'd end up bouncing off of the top or the bottom stop. So the next thing I'm going to do with the machine running is I'm going to go back and hit that program key again. Now I'm back under dynamic tuning. I'm at the same place. I'm going to hit the down arrow to go in this menu. That dynamic tuning means that the system is running. You have to tune it with it running. Now, I do have direct access to PID. I can go in and put those values in. But you don't have to be a controls expert to tune one of these systems. You just need to be able to recognize the difference between unstable and stable just by holding down two buttons. And that's what I'm going to show you. So you would do this in two steps. There are two steps. You would do it first with a full roll or near a full roll of material. A little bit easier to do with an unwind. In the case of a rewind, you'd have to get a pretty good size roll and just give yourself time to do it before it was completely full. Then we would go through and repeat that same step at core to do the two-step tuning. Now in this case, I'm not changing diameters down here, so I'm just going to do it in one point. But now that I'm here, I've moved my cursor over under full roll, and I can do a couple of things here. One thing that I can do, remember I taught this by holding the plus and minus key, I taught it where the center point was. If I don't like it, and I'm looking at it right now, and it could probably be a little lower, I can actually change that here. So I'm just hitting that arrow key, and you saw the arm drop. That was actually changing that set point that I taught it. Okay, so now I've dropped the arm down where I want it. Now the next thing I'm going to do, under full roll, is I'm going to go in here and hit the minus key. I'm actually going to hold the minus key. And what this is going to do is actually going to increase the gain. And what the gain is how much it reacts, how much the control reacts to a given error. So the more gain I put in, actually the more unstable it will become because it will start overshooting. It's going to react too much. So you can see right now, before I do anything, you can see that it's pretty stable. But I'm going to hold the minus key. Now in a moving machine, you don't have to do this, but since I have a static demo, I have to help it a little bit. But I'm going to start introducing a transient. So you can see now the arm has gone unstable. And the longer I hold it, the more it'll bounce. And I can hold that down until it's bouncing clear up off the top. So now that it's gone unstable, now I'm going to go in here and I'm going to hold the plus key, which is stabilizing it, which is decreasing the gain. down to that optimum point that's right on the edge. So you can see it's stabilized out. There's still, you can see there's still just a little bit of a bounce to it. I'm just going to hold that just a little bit longer. Now you can see that it's springing right back to where I wanted it to be. Then I would go in and do the exact same thing at core. Then I would go in and exit. Now, if I was a control expert, I can go into configuration, and there are multiple things in here that you can do. We talked about, the different features and things that you can add to it, like the sensors and the current to pressure transducer and the gain scheduling. We're not demoing all of that stuff right now, but I do have direct access to the integrator, the proportional gain, and the derivative. So you can see right now, my integrator ended up at 1/2 second, so it's going out and looking for an error every 1/2 second. Our proportional gain ended up at 2.37. Now I can change that value if I think I'm smarter with the control. Let's just put a value of, let's just put a value of 6 in there. Now what you'll see, I'm going to hit home again. You can see it went unstable again. So I can go in and directly, by hitting program, affect what that is. I'll take it back to the 2, and it automatically set it. So I have direct access to PI and D, but the bottom line is, you don't need to even understand the relationship of those things. Really all you need to do is go in, hold the minus key to destabilize it, hold the plus key to stabilize it, and you've tuned the system. And it will automatically set PI and D for you. Now another thing that I want to show you that's critical in any closed loop system, this is a very common mistake that we see out there. In a closed loop system, you have this control loop running. P is the proportional gain, I is the integrator, D is the derivative. It's how quickly the control adjusts. If I were to stop this machine, so let's just stop the machine. Okay, so everything stopped moving. I turned the motor off, but I did not turn the control loop off. Note that I'm still in automatic. This control does not know that the machine has stopped because I didn't tell it. And you can see it's integrating up right now through 60%, and if it had stopped low, it's going to go even faster. So right now, the operator has stopped the machine just by stopping the web. Didn't turn the control loop off. Now when he goes to turn that machine back on, look where our output has gone. It's gone clear back up to 100%. And watch what the arm does when I turn it back on. Now my arm has gone up, hit the top stop, until it can integrate back down to that point. And as soon as I hit that stop, I have lost my tension control. Remember, it's only a tension control if it's not hitting the top stop or the bottom stop. So it's very important to connect what we call a run-stop connection on these. So rather than using the speed of the machine to stop the web, you should use a run-stop connection. In this case, we've got a switch here. And if you look at the screen, you can see it says A, which is automatic. When I hit that stop, it goes through a stop sequence and goes into hold. And what that did was it turned the integrator off, which pauses or holds the control loop. So now that I've used the controlled stop, when I turn it back on, I start right back off from that point. This concludes our presentation on dancers. For more information that might pertain to your specific application, I would recommend that you contact your local MAGPOWR distributor, local district manager, or the factory to discuss your dancer application or any other tension control applications that you might have. Also, in addition, we do offer a white paper on the critical design aspects of dancers. This will be located on our website. Thank you.